So here's an exercise for you. What is the basic knowledge you need in order to automate a website? Now what I want you to do at this point is to get hold of a pen and paper, because you're going to stop the video. In fact, I'm going to stop the video for you. We're going to stop this video early so that you can do this as an exercise. And the basic thing I want you to do is I want you to think about what are the basics that you need to know so that you can automate the web. Now I know you could cheat. You could just go back, look at the course list and go, oh, we need to know manipulation and alerts and frames and windows. Don't do that. Right? Don't go back to the list and figure out. Just have a think. Just think, what kind of things do I need to know? And there's a reason for this when you get to the end of this exercise. And the reason is all about chunking this knowledge. Thinking out how to organize the knowledge to make it easier for you to remember it and figure out what you need to do in the future. So I'm going to ask you to take, for a couple of minutes, 2 minutes, 3 minutes, 4, 5, however long you want, and just take your pen and start writing it out. Whatever basic knowledge you think you're going to need. So here's a starter for 10. Starting different browsers. What else? Going to a URL. And whatever else. You go away, have a think, come back with your list. Now I'm going to, as the answer, have a very, very small list, so don't spend too long on this. But what's important here is not so much the list, but how we use that list and chunk it. So go away, figure out, have a think, what is the basic knowledge you think you're going to need in order to automate the web. So your mission, and I hope you chose to accept it, was to take a couple of minutes and think through what you thought the basic knowledge for automating the web is. Now you'll have a list now. Here's the absolute basic list that I created. So we need to be able to open a browser, you know that. We need to be able to navigate to pages. We need to be able to read page titles and the URLs in order to check where we are. We need to be able to get text from the page because we're going to have to look at the information that's there and act on it. We need to be able to click links, that's obvious, that's something that we do all the time. We need to be able to fill in the forms, click on the drop downs, choose the different radio buttons, various other things. And we need to be able to submit forms by clicking on buttons and interacting with the page. Now you may have a longer list. Now what's important about your list, if you do have a longer list, is that as we go through the course, if we get to the end of the course and you have something on your list that we have not covered, what I want you to do is get in touch with me by clicking on one of the links or leaving a comment or emailing me directly and saying, Alan, this is really important and your course doesn't cover it. And I will either respond to you, that is not really important and there's a reason why the course doesn't cover it, or more likely, I will add some content to the video to cover the gap that you have spotted, if it is really important and it is something we need to know. But the other reason for creating that list is because if you maintain a giant list like this, you will get lost. It's one of the problems that the Selenium RC API had. It was just a giant list of commands. Now let me try and demonstrate this to you. Now in Selenium RC, the API was just a big list. This is one of the tests we're going to cover later because Selenium RC is still supported in WebDriver through the use of a WebDriver-backed Selenium driver. Don't worry if you don't understand this at the moment. The important point here is not the test, it's not the information in front of you. It is this that I'm about to show you now. It is the Selenium dot, and here comes the API. This is the list of methods that were available through Selenium RC, and it is not at all categorized. Basically with Selenium I can click on stuff. I can wait for things. I can add custom headers. I can add scripts. I can alt key up and alt key down. I can assign IDs. I can capture screenshots. I can click at various points in time. I can get a context menu. I can do specific control key ups and key downs. I can drag. I can fire events. I can check for alerts, windows, various other parts of the screen. I can get CSS counts, cookies by name, element. And all of this stuff is important. These are all things that we want to be able to do. This is what you've just done. You've done a list of what do I need to be able to do on the web. This is what the Selenium RC API creators thought you needed to be able to do when you automate, and it is a big, big list. WebDriver doesn't work like that. WebDriver has a much, much smaller API because they have categorized the API. Now they have made various decisions about how to categorize it that may or may not be obvious to you. I think about web automation using these 4 basic concepts. When I'm automating the web page, I want to be able to navigate. I want to be able to navigate around the application. That means opening browsers, navigating to specific pages. I want to be able to interrogate what's going on. I want to be able to pull information out so that I can use it. So from the basic list that I created, reading the page title, reading the URL, getting text from the page. Other things would be given a particular ID, show me the text for that element, show me the contents of a particular dropdown. All these different things are interrogation. I want to be able to manipulate. I want to be able to click on links to allow me to move around. So clicking on a link, I am making a separation in my head from navigation, because clicking on a link may trigger some JavaScript. It may not always navigate. Clicking on a link is doing something. I want to be able to fill in forms. I want to be able to select from drop-downs. I want to be able to click on buttons. And I want to be able to synchronize my tests. This is one of the most important things, even though I've got it on the tail end here. The ability to synchronize and have our tests operate at the same speed as the web app and in line with the web app, so that we're waiting for the particular web app events to happen rather than waiting for 3 seconds before doing something. We need to be able to synchronize our tests with the web application. And this is fundamentally how we are going to organize our knowledge of the WebDriver API in terms of our ability to navigate or interrogate or manipulate or synchronize. And when you get in the habit of thinking in those 4 concepts, the WebDriver API is something that supports you in doing that. So for me, the basic knowledge that we require for automation is not a big list of things. It's how to navigate, it's how to interrogate, it's how to manipulate, and it's how to synchronize. And we're going to go into that in more detail now and split the API down into those concepts. So let's have a proper look at JUnit. JUnit is the test execution framework that we're going to use. We've already seen a little bit about JUnit because we have added it into the POM and we have created a first WebDriver test using it. But we're going to take a look at JUnit in isolation for a little while so you see what it does, some of the flexibility around it, some of its usages. A lot of people get hung up on the fact that JUnit, unit test framework, and we're going to be using it in a non-unit testing context. But the important point is it's our test execution framework. It's what we're going to use to build up suites of tests. It's what we're going to use to run our tests within. It's what we're going to use to collate the results and assert whether the conditions that we're testing for have happened or not. It's our execution framework. So don't get hung up on the JUnit name. It's an execution framework. So as before, the home for JUnit is JUnit.org. JUnit.org has a lot of good documentation on JUnit and how you use it. And it is worth, with all the tools that we're using here, it is worth reading the documentation. And as with all the tools that we're using here, the most up-to-date documentation is in the actual source code itself. And if you have a hunt for blog articles, you'll find more information on JUnit. Because JUnit has an enormous amount of flexibility. Now, when I first started with Selenium, we were using testng, and we used testng for our test execution framework because it had data-driven testing support that was a little bit better than JUnit, and it seemed to offer better suite management and various tagging. JUnit has undergone constant improvement over the last couple of years and is now astonishingly powerful. It's just that a lot of the power comes from writing your own custom runners or JUnit rules, and some of those parts of functionality are hard to find within JUnit. They're almost hidden. They're well documented through blogs rather than the actual JUnit documentation. For our initial purposes with WebDriver, we don't need to know very much more than what we're going to cover over the next 5 minutes. But still, have a look through the JUnit website and get a feel for JUnit itself. So, JUnit basics. In order for us to use JUnit, we add it as a dependency to the POM. You've already seen that. In fact, you've already seen me add version 4.10 rather than 4.8.1 as I've documented here. You know about JUnit.org, and you know that in order for a method to be treated as a test, in the JUnit 4 version that we're using, we annotate the test with @test. In JUnit, we assert that conditions happen through the use of the assertion methods: assert true, assert equals, assert false, assert null, assert not null, etc. And the assertions take the form of a message, the expected result, and the actual result. And if you get in the habit of always putting a message in, always putting a description in, your tests will be more readable. You don't have to put the description in, so a lot of people in their tests don't put the description in. But then what happens is they get used to not putting it in. They get used to not making their tests readable. One thing we want to do with our test code when we use it in production is make our tests as readable as possible, because that makes them as maintainable as possible, and that starts communicating our intent better. Even if we don't build up any abstraction layers in our tests, the fact that our assertions have descriptions and messages in them makes our tests more readable. So here's an example. Here's a very example of JUnit on its own without using Selenium or WebDriver or anything else. So you can see that in order to use JUnit, we have to import the JUnit test annotation. You can see here that I've imported the assert equals, and I've imported it statically. That means I don't have to write assert equals in my test. Now the test class itself has test in there. This is an important point to remember, because Maven by default will run tests that have test on the name. If you don't put test on the name, you'll have to write additional code in the POM file for it to pick up and run as part of the Maven test command. So get in the habit of using this test in your name, and try and make the name as expressive as possible, because in your test documentation you have a number of documentation points. You've got the class name, that can be expressive. You've got the test name, that can be expressive. And you've got the assertion message, that can be expressive. Now you can see here I haven't done that. Well, in a sense I have, because I'm expressing to you that this is just a JUnit example. It doesn't do anything else, it's just an example. And this is a basic JUnit test. Now I could have called this 2 + 2 = 4 test. I could have said when I use assert equals as my class name, I could have done a whole bunch of things to make the test more readable. So let's have a quick look at a JUnit test in IntelliJ. Okay, so let's just create a JUnit test in here. So first things first, our POM has JUnit in here as a dependency. Let's tidy this up a little bit. So we currently have 2 dependencies in our POM. We have a very, very simple POM here. It just has all the metadata for our test. It has a dependency on JUnit 4.10, and it has a dependency on Selenium. So when I start writing my JUnit test in here, I know that JUnit is already in here as a dependency, so I know I can do all my imports. So let me create a new package to put this in. I'm going to do com.jUnit Selenium simplified dot, in fact I'll put it in here, Selenium simplified dot JUnit. There we go. So let me create a new class. I'm going to recreate the example that we had there. So JUnit example test. Let's get rid of this. So I need to annotate my method with that test. You can see that it has imported it up here. It's marked as red because there is nothing to annotate. We haven't created the method yet. So I'm going to create a test. I'm going to call it 2 plus 2 equals 4, because that's what the test is doing. I'm checking some addition. Now I want to do an assert equals, say 2 plus 2 equals 4. Then what am I expecting? I'm expecting 4. And it starts with 2 plus 2. So the assert equals has not been imported yet. So I'm going to do an Alt-Enter in Eclipse. And I'm going to choose static import method. You can see here we have an assert equals coming in from r.junit and an assert equals coming in from JUnit.framework. This one has been deprecated, which means that in a future version of JUnit it's likely to be removed. So we'll choose the one that is not likely to be removed. That will keep us forward compatibility for a while. And you can see here it has imported statically JUnit.framework.assert equals. If I run the test by right clicking on this and doing run 2 plus 2 equals 4, the test will run and you can see that it has passed successfully. So what would happen if I change the message? Well, let's leave the message. What would happen if I change the test? So 2 plus 2 equals 4. I'm going to say that I'm expecting 2 plus 2 to equal 5. Let's see what happens. So you can see, because I put this message in, 2 plus 2 equals 4, that is what is displayed in the output. The more that we make this descriptive, the more that we make this so that it helps us debug our tests, the more useful it is in terms of helping us pinpoint problems and documenting the test. So 2 plus 2 equals 4, I expected 5, but the actual answer was 4. So from this we can easily see that I actually got the expected number incorrect. I could have made this something like addition should be done correctly. Let me change this back to 5. And when I run this, we see addition should be done correctly, expected 5, but was 4. In order to debug this, I'm going to have to go into the test. This link here should take me exactly to the line that has the problem. I can analyze it and see addition should be done correctly. Clearly this should be 4, like that. Now let's have a look and see what happens if I don't put the message in. I'll make the test fail. So you can see here we now have an assertion failed error. We expected 5, we actually got 4. Okay, that from here I have no idea what context this happened in, so I have to go to the line. Now here it's obvious what's going on. In other cases, when you start writing lots and lots of tests on your application, over time you'll forget, possibly, why that test is checking the things it's supposed to check. That's why the test name is really important, and that's why putting a descriptive message into your certs is really important. So if you get in the habit now of doing this, it's a practice that you'll carry on going forwards. So I'm going to make this 2 plus 2 equals 4. It's a very simple example. Normally I wouldn't necessarily repeat the calculation in here, but I'm going to do that. And I'll fix it so it's correct. So there we go. Now I have a valid test again. 2 plus 2 equals 4. And because this is called test, if I did maven test from the command line, this would run. In fact, we can try that. So if I bring up conemu, I'll go to my project. So if I do maven test, it has failed. Okay, so that's got a Java runtime 1.7.0. The compiler may be using a different version. So let me try a maven clean compile on this. Maven test. So you can see that's running now, and that's because when I did a maven test, it was using the compiled versions that had been compiled in the IDE. And the Java runtime, or that it's using from the command line, is clearly different from the version that was in the compiler. So I may have to change my settings. So I suspect Java has updated in the background and the correct JDK has not been downloaded. So if you experience something like that, you can see that there's nothing major going wrong. It's not something you've done. But when you've run it from the command line, do the compile first so that everything is up to date with the version that you've got running in there. So let's have a look and see what happened. So you can see here that JUnit example test has been picked up. The Selenium test, the WebDriver test that we put in has been picked up. And we did not have to do anything. We didn't have to add anything into the POM. They were picked up through the maven test job simply because they have test in the name and they're under the test package in the maven project. So I think it's worth spending a little bit of time going over the basics of Maven, how it works, what it's actually doing in the background. Because what we've seen is that all I have to do is put a dependency in the POM, and as if by magic, all the stuff that I need to happen is there. So how is this doing? We're not going to do this in detail, but at the most basic level, what is going on? We've already seen the home page for Maven. This is where you'll learn about Maven. This is where the documentation is. You should read all this stuff to see what's going on. Now what we haven't seen is the central repository. Okay, so maven.org is a central host for things that are published into Maven. So if I do a search here for JUnit, because we've used JUnit, you can see JUnit, latest version 4.10. And we can actually download the jar. If I want to, I don't have to bring it in through Maven. I could, if I'm using Ant, just download the particular jar that I want, or the Javadoc, or the sources, whatever else. But you can see here that Maven, when it does its work, knows to download the jar. And when we zoom into it, I haven't shown you this bit yet, but when we zoom into it and say, get the sources for me, it downloads the sources jar for us. So you can see we have JUnit. There's JUnit with its dependencies. Here's all 18 versions of JUnit. So in Maven, I could choose 4.3. I could change my POM to download 4.3. It would come here and download 4.3. And where does it download it to? Well, on my Windows box in my user directory, there's an .m2 folder. This is my local Maven repository. And look in here, you see a whole bunch of stuff because I use a whole bunch of stuff in different projects that I'm using. But there's JUnit. And I have version 4.10, 4.8.2, which you saw on the slides earlier on. This is where all the different versions are stored. Selenium will be in here at the different versions of WebDriver. Org dot Selenium HQ, Selenium, all the different drivers, all different versions, all different things that we've been using. And there's 2.25. So what's going on at its most basic level is we have a local repository. This is where Maven will first of all look to see whether the dependencies exist. If the dependencies do not exist here, then Maven will go off to the other repositories that you've defined in your Maven setup. Now, I have not defined a Maven properties file in here, so by default it's going off to the central repository and pulling stuff down from there. I have not set up Nexus or any other local repository to cache this stuff for me. So I basically have a local repository in the file system that Maven is pulling down to, and the central repository that other people are publishing to. So that in a nutshell is how Maven is working. So let's quickly demonstrate that the test name is what's making a difference to Maven. So let me rename this. If I do a Shift F6 in IntelliJ, that brings up the rename refactor. That's a bit extreme. Let's call it JUnit example. Now if I jump off to this one, in fact, since we're here, let's do this through shortcut keys so that you can see this. So you can see here I did a refactor rename, which is the Shift F6. I want to go over to this first test, but I'm going to do that by doing Control N, enter the class name. I'm going to put in FT for first test, and it shows me in the list. So if I hit enter now, I'll go off to that test. It's worthwhile learning the IDE shortcuts to make you a little bit faster in here. So again, I'm going to select the name. I could right click, refactor, rename, or I could click on it, Shift F6, and let's call that first. So now all those things are saved. If I jump back to the console, and now I'm going to do the Maven clean compile test so that we don't have any issues. And you see there, no tests were run. So let me go back and fix that up again. Now IntelliJ has this handy local history. So I can see that I renamed this. So let me revert to that. So let's change that back to first test. So that's renamed back. Let me get this. Let's do the local history for this. I did a rename here. Let me revert that rename. So although we haven't gone through the process of installing a version control system and checking in our code, which is a very useful thing for you to do, IntelliJ gives you some local history and local ability, local version control just built in. So that's our test back to normal. Oops. I've gone too far back. So that was actually a terrible example of the misuse of the local history version control built into IntelliJ. So do not learn from my mistakes. And so back to learning more about JUnit. Now we've seen the most basic that we can do with JUnit, @test and an assert. Clearly there are more asserts. We can do assert true, assert equals. Clearly we can do much more with JUnit. Now we can avoid repeating code in our test methods by using things like before, and @after. @before and @after allow us to annotate a method with @before, and when I annotate it with @before, that method will be run before each and every @test annotated method. I'm going to show you this in a moment, so I'm just covering the theory just now. If I annotate a method with @before, it runs before each test. If I annotate a method with @after, it runs after each test. I can also do test setup and tear down at a class level. So if I have multiple tests in my class, if I do an @before class, the method that I annotate with @before class will run before running any of the @befores and before running any of the @tests, and it will only run once per class. If I annotate it with @after class, it will only run after all the tests, and it will only run once per class. And that @before class and @after class methods have to be declared as static. And that means if they use any fields in the class, those fields will also have to be declared as static. So let's just quickly explore that so that you have a better feel for the capabilities of JUnit. And you're going to do an exercise in a minute where you're going to explore this for yourself. But this is the very basic thing you need to learn. And back into the world of the IDE. And this is where we prefer to live. Let's face it, we're automators, we're testers, we're developers. We prefer to live in the IDE, in the land of code. So, what do I want to show you here? Well, in a minute, or in a couple of seconds, however long this takes, I'm going to show you the @before, @after, @before class. What I quickly want to do is show you, if I do control-click and assert equals, I get to see the JUnit source code. So, if you haven't already done it, when you do control-click, you'll see a little message up here that says, "Can't find the source code for that, do you want me to download it?" And you'll say, yes, I do want you to download it, and you'll click on the download link. But then what will happen is, we can see here, because I have the settings set up to auto-scroll to and from source, you can see now that we've jumped to the source file, and in the project hierarchy is the full JUnit jar. I can jump through this and see what else is available to me in JUnit. I can see the assert class, and in the assert class, if I do, that was Control F12 by the way, Control F12 shows me the members that are in this class, a nice little view here. I can see all the different assert methods that are available to me. So you can see here, this assert equals takes a message and an integer and an integer. This one takes a short. So all the different combinations of parameters for polymorphism exist in here so that I can use the method in different ways. And you can see that it's static, so that in my test I have a choice. I can either do assert, overzealous completion. I can do assert dot assert equals and pick the method up that way, in which case I'll have to import the assert class, or I can import it statically, as I've done here, so that I don't have to put assert on the front. Now, different people have different coding styles. Some people don't like static imports. I personally don't mind. I think having assert dot assert equals doesn't aid my readability in any way, so I will import it statically and just write assert equals. You get to choose, or your boss gets to choose, whoever it is that's most important. But you can see in here, for the assert, we've got the different combinations. Assert not null, assert not the same, and we can see the different things that we can assert on. So I can assert on floats, integers, longs, just a general object assertion, which will do an equals on that particular object. And this is how you're going to learn the capabilities of the frameworks and libraries that you use. You're going to learn how to jump into the source and read what is there within your IDE. Bear in mind, all the comments that you're going to need are here. If I jump back to the JUnit example and do a Control Q on this, I'll see some documentation. That's the same documentation here as I get in the Java.doc comments in here. And we can jump through and get a feel for what JUnit is capable of. I can see here there's a thing called a test suite. I wonder if I use that. Well, I must be able to create suites. I can then go away and learn about how to do test suites. What might a test listener do? Well, that's something that I can use to set up a rule and monitor my tests as they run and increase the capabilities of my test framework in JUnit. And this is how you're going to be able to start answering your own questions about the frameworks that you use, by reading the source code that they have. And let's have a very quick look at the @before and @after annotations. So I'm going to create a new Java class here. I'm going to call it JUnit before and after, because that's what we're going to have a quick look at. I just did a whole bunch of Control W's to expand out the selection there. So, JUnit before and after. What I'm going to do here is I'm going to create an @test, and what I'm going to do is, that was preempting, I'm just going to do some system.outs so that we will see things happen in the console, so that you see the order of what's going on. And I'm going to give these really bad names, so I'm just going to call this one test. There we go. There's a nice really bad name for you. All this is going to do, I'm not even going to put any asserts in here. I'm just going to do system.out.println. This is one test. Now, I'm going to have to create multiple tests so that we see the difference. Now you see here this is red because these both have the same name, so we'll get rid of that by changing the name. Now I have this 2test and this is 2test. And let's create a third. Now these aren't really tests, they're just methods that have been annotated by test, because remember, JUnit is our execution framework. So if I run this class, run JUnit before and after, what we'll be expecting to see are over here in the execution, the running of 3 different tests. But over here, I'm expecting to see the system.outs for this is 1 test, this is 2 test, this is 3 test. There we go, everything passed. So let's see what happens if I do an @before on a method. Public void before test, I shall call this. And again, I should do system.out.println, and I will say before test. Now I tend to put my befores at the top and my afters at the bottom. That's just the ordered, tidy person that I am. I will say after test. Now based on what we covered in the theory section, if I run the class now, what we'll be expecting to see is before test, this is test 1, after test, before test, this is test, this is 2 test, after test. That kind of output. And good. I did not lie to you. Before test, this is 1 test, after test, before test, this is 2 test, after test. Now, One thing to be aware of, just because we've added the tests in this order is no guarantee that they will run in that order. They have done here, but there's no guarantee of that. So do not create dependencies on your tests where you expect the order of the test to happen. Do create dependencies on the before methods or the before class methods or setup methods within your test, but do not rely on the ordering of your test to set up post conditions or teardown. So now we can do something at the before class level, something that will run once per class. Public void before class. Now those of you that were paying attention in the theory section are expecting me to do something that I haven't done yet. And the reason why is I'm going to show you what happens if you don't. So I have a method before class, annotated before class. So I'm going to run this. And let's see what happens. And we got an error. Now we didn't get an error at compile time, but we did get an error during execution where it says before class should be static. And that's because JUnit uses a lot of reflection when it's executing with its runners. And it's picked up. We need it to be static in order to access it through reflection because of the runner, and to do it once per class. So I have to say public static void before class. That is pretty much what I'm going to repeat in a slightly different form for after. So just to make my coding easy, at after class, let's Alt Enter to import that. Let's say after class. And of course the danger with copy and pasting code is I may forget to actually change the body. I haven't. So now when we run this, what we're expecting is the before class method to run once and at the start. Then the before and afters for each test, with the test sandwiched in the middle, and then the after class at the end. Great, so we have a before test and no before class. That was unexpected. Now I saw that come out before class in there and appear down here. That was wild. Now, I think this is working fine, but what I'm going to do is I'm going to put debug points in here so that we can see this. Because I think it's working fine, I think it's just the console and buffering, whatever else. So if I right click on this and debug it, so there I am. We haven't done anything yet. There's nothing in the console. I'm at the before class. So if I run down to the next one, now console says before class. It's gone away because we're now in here. And now we're in the before test. Now we've run the test. Before test, this is test 1. We saw it before class came up, and there it is. Or would be if the buffer was working properly. And after test. So you can see now I'm back in the before test. We haven't hit before class because we've already run that, and that one runs once per class. Now we're in a before test. So you can see the ordering is there. But the magic of the IDE is showing us a slightly unexpected thing in the console. Interesting. Now if I run that command line, I expect to see the console populated correctly. So I'm going to say maven compile test, the maven clean compile test, and I will fix the JDK JRE before I do this again. And of course, because I didn't name this test, it's not going to run in Maven. So let's rename this. There we go. Now when I do run Maven correctly this time, this test will run. Hooray! Everyone say hooray, because that was quite a painful way of demonstrating this. But you can see that the JUnit before and after test has run, and the messages that we were expecting to see have appeared in the correct order. Now you're about to do an exercise in JUnit where you're going to have to use the at before and at after, and we're expecting you not just to use system.outs but possibly create some multiplications, minuses. And so in your before classes, when you use fields up here, if I'm going to use an integer, I will call it addition sum equals 4. Now if I want to use that in the before class, I will have to make this static so that I can access it in here. Now let's have a look. Addition sum equals 13. It should complain, which it does. It says that's not is a static method. This field is not static. You cannot use that in here. Therefore, I have to make that static. In the instructions for the exercise, when you see me referring to assign a value in a field, if you do it in the before class, you need to make it static because this is static. Okay, this is your chance to shine. So we've just briefly covered JUnit. You've seen where the documentation is. You've even seen some example of JUnit tests. What I want you to do is spend a little bit of time exploring this on your own. So try and create a test that uses assert true and use different combinations of the arguments. Try and create a test with assert false. Try and create a test with assert equals. And remember when you use assert equals that the parameters are message, expected value, actual value. Use at before to create a field that is assigned in the at before method and used in the test. Do the same for at before class. Spend a little bit of time reading through the documentation to see what the capabilities are. Explore the source for JUnit in your IDE, so make sure you click through into the JUnit methods and attach source. And do a little bit of investigation on one of the methods that we haven't covered, the assert that method. So in order to do that, you'll probably have to create a test that tries to use it, jump through into the source code, look at the Java doc, look online for examples. And assert that is a very flexible method, as you'll see when you start using it. So take some time, spend half an hour or however long it takes for you to do all of these things, then come back and I will walk you through the example tests that I have created to meet these conditions. They may be different from yours. In fact, they probably will be different from yours, but you can see what I did and then compare it with your work. And we'll also go through the assert that bonus points just in case you don't get a chance to do it. And we will explain how to attach the documentation in IntelliJ if you haven't managed to do that. So go now, best of luck, let's see you back here in half an hour. Welcome back. I'm just going to start by running all the tests so you can see that everything that we have done, or everything I'm about to show you, does pass. There we go. JUnit tests are particularly quick, which is why I ran that there. They ran through very, very, very quickly. And that is why when we do automation work, if possible, we like to push tests down to the JUnit level or the unit test level as much as we can. If you are identifying scenarios and conditions that you would like to see tested in automation, and you have the opportunity to push them down to the unit test level, then that is a great thing to do. You might want to do them at a higher level in integration tests or functional tests as well, because you're doing it in a different environment or because it's doing some sort of integration. But if you can have the functionality demonstrated at a unit level as much as humanly possible, then you have the option to make a more informed risk assessment about what tests you write at a higher level. So you were tasked with a bonus question to use assert that. We will cover that. You were tasked with using assert true and assert false and assert equals. These are the most basic asserts that you will use, and I hope you took the opportunity to practice using different parameters. You had to do some work with the @before and @before class, and that will force you to understand a little bit about fields, reusing variables between tests, and setting up the necessary conditions for a test. And you can see that I have set up two fields here, one for the @before and one for the @before class. So let's have a look at the test that I wrote. So for assert true, the most basic, I created an assert true. I put in a message saying true is true and then just added true. This will assert that true equates to true. I've also put in a number of other ones to test the evaluation of a true condition. So 3 plus 3 equals 6 results in true, even though it's a sum that we're carrying out. And then I've done a string comparison where the answer as a string has the equals ignore case method to check the string variable that we set up here. For assert false, I've done much the same, where I've negated true to get false. I've done a calculation, and I've done a string compare. On this one, I have checked that the string does not contain the. So this says assert false that an answer contains the, and this will return false. And you can see that I'm always putting a message in here because otherwise it can be hard to understand what assert true and assert false are doing sometimes. So for assert equals, again I have put the message in because it's important to know why you are comparing sometimes. And what's important with the assert equals is that if you get these the wrong way round, where this is expected and this is actual, it can make your tests hard to read. JUnit won't mind. JUnit will run them. JUnit will let it pass. If I swap these round, JUnit will be quite happy because all it's doing is comparing strings. If I run this, that passes fine. However, anyone coming to read it who knows that I have a message, I have my expected answer, I have my actual, can get confused because my actual is a string here and my expected is a variable. Now, it's probably obvious when I'm using a string literal here that I've made a mistake and gotten the wrong way around. But if I was using two variables and they were both constructed through calculations, and this was just assert that equals one variable containing the results of a calculation with another variable containing the results of a calculation, they would get confused as to knowing which one was expected and which was actual. So be very, very careful that you get these the right way around and you put the expected, then the actual. That will make your test much more readable because you're using the contract that is set out by JUnit, where it's a message, it's expected, it's actual. I'm labouring the point because I get this wrong sometimes and it makes my tests harder to read. Okay, so here we're looking at the @before. Now @before, remember, runs before each test method. So in these preceding tests, this @before ran before each one of these. We didn't care because we're only using it in one particular test. Remember, @before has a sibling method, @after. So typically, we'll set something up @before, and then we'll have another method @after, which cleans up the results of the test, or closes files, or closes browsers, things like that. What we tend to do is we use the @after to do this, because a test can fail with an assertion, whereas @after will always run. Regardless of whether the test is passed or fail, the @after will run, so it's a great place to do your cleanup. So you can see I have a field called I set this before. I set this before, up here at the top, when the class starts, has a default value called setAsField. In the @before method, I change it to setBefore. Then in the test, I check that the value has been set. If the @before method had not run, then it would still be the same value that was set at the top of the class. Because both of these pass, I know that the setBefore worked and the @before method was run before this test was run. So what I'm doing here is I'm asserting that the string setAsField does not equal the current value in the variable I set this before, and I assert that the value that I'm expecting to be set in the @before is the value that the I set this before variable contains. So the @before class. This is using a very similar method where I have a field that I have set to a default value at the top of the class. Now the difference between @before and @before class, remember, is that it has to be static because it's running at a class level. So at the class level I set this before class as default. Then in the @before class method I change it to be for all class methods. Then in the test, which is using it, I check that the default value that we set at the top is not, I assert false, is not equal to the current value. And I check that the value I'm expecting to have been set in that before class is the value that has been set. So hopefully they were fairly simple because they were what we had covered before in the previous tutorial. Now you were also asked to explore the documentation at JUnit.org. Now this is really just my way of forcing you to go and read some documentation. You've got the Java doc and you can see all the classes. Now if you had read through this, and I hope you had, you can see the Hamcrest matchers that we have in here that you were asked to experiment with. You were also asked to look at the source code in your IDE. Now you do that by control and click through into the method. And you can see here I have detached the source to demonstrate how to reattach it. So if you did that, hopefully what happened is you saw sources not found, and then you would say download sources, because you're using Maven so it can go off and find them for you. Now if you download the sources, hopefully IntelliJ will go away and find them because you're using Maven. Because I've detached them manually, I have to attach the sources, and here they are here in the Maven repository because they were downloaded previously. And there you go, now I've got the source code for the JUnit, and I can just drop down into all the different methods and see what's going on. Now that would really help when I start looking at the matcher exercise, because we can see here. Now matcher can look really confusing because it's using generics, and you may not have learned generics yet if you haven't done much of Java, but that's fine. It's something to put on your to-do list to learn, because generics are a really powerful part of Java. But you can use this without having to know what generics are. So you can see here that for the Hamcrest, I haven't put in a message in the test. What I've written here is very literate. I'm saying that assert that the answer is not an answer. So instead of doing an assert false and then doing a string and an equals, I am doing assert that this string is not this string. And that's using the inbuilt Hamcrest matchers that JUnit comes with. So hopefully if you went through the documentation, you would have seen documentation for Hamcrest. You can see that I'm using the assert that is method, is matcher with the not matcher. Is, and in the is not, you can see that it has a not method. And you can see that the null value, so JUnit is supplied with a subset of these Hamcrest matchers. And you can also see that JUnit has some custom matchers. Where we've got a both method and contain string and either. And these have examples in the Java doc to show you how they can be used. Now this allows you to write your conditions much more literate style. So I have used this particular one in the test here to say, assert that the answer both contains the string the and contains the string answer, which is a much more literate style and makes your tests less demanding of having a message at the front. So hopefully as you go through you'll experiment with traditional assert true, false, equals, various other methods, and with the Hamcrest style matchers to make your test more literate. I will probably mix and match between them both. In fact, I will probably use the assert equals true, false much more often than I will the matchers, because I'm trying to keep this as simple and basic as possible. But for your exercises, please experiment with matchers. It's a very useful habit to get into, and it can make your test much more literate. So for those of you that experimented with Hamcrest, good for you. Now, you may have encountered the issue that JUnit comes with a small subset of Hamcrest, and when you looked on the Hamcrest website, you saw all this other cool set of functionality that you wanted to use, but it wasn't there. You tried using greater than, whatever else, couldn't do it. So we're going to have a quick look at how to do that, because JUnit bundles in part of Hamcrest, and in JUnit 4.10 it bundles in part of Hamcrest 1.1. Hamcrest itself, at the time of creating this lecture, is on 1.3. So how do we use the rest of Hamcrest 1.1, or how do we use Hamcrest 1.3? What do we do? This is not an uncommon problem. There's various other places on the web that you can find this information. This particularly good case study of how to do it. Other people in this issue here have given answers for what to do. I'm going to run through what I've taken from those links and various other places to incorporate this. So what we normally start with, so this is our basic. This is JUnit 4.10. This gives us some parts of Hamcrest. So you can see here I'm over now in the JUnit 4.10 jar. I have some basic Hamcrest in there. There's some JUnit matchers, and we've also brought in the Hamcrest core for 1.1. So I have the matchers in here as well. But that's not the full set. Now JUnit provide their dependencies. Let's have a quick look on Maven. So JUnit dep is JUnit without the Hamcrest. However, it still depends on Hamcrest core 1.1. But what it allows us to do is bring in the full version of Hamcrest, so long as it's 1.1. So let me do that. So I'm just putting all this stuff in the main Maven file. So because that's XML, I'm just commenting out these various parts and making other things enabled. So if I want to use JUnit 4.10 and Hamcrest, what I'm going to do is bring in the JUnit dep dependency instead of the full JUnit one. I'm still going to bring in 4.10, that's most up-to-date one at the time of writing. There is a beta 4.11, but I'm using 4.10 here. And I want to bring in Hamcrest, and I want to bring in all of Hamcrest. So what I'm doing is putting Hamcrest all 1.1 as a dependency before the JUnit dep one. Therefore, the Hamcrest code will come in, and it won't use the JUnit one. Okay, so now that I've brought that in, let's have a quick look and see what happens in this test where I've got an assert that greater than. Greater than is not part of the core. Greater than is now in there. Where is it coming from? It is coming from Hamcrest all 1.1. So I've got the full Hamcrest in here now, and I can use it as part of my tests. If I want to go beyond 1.1, now if you look on the various websites, mailing lists, some people go and stick with 1.1, that's very stable, 1.3 has issues, etc. Your choice, see what works for you. What we're showing here is how to do this. So further down here I've got this. Now Maven, as part of its magic, and Maven is magic, I don't fully understand its magic, I learn what I need from the various websites that are out there that tell me how to do this. So if I want to use 1.3, which is what I'm saying here, I want to use Hamcrest all from 1.3, in JUnit 4.10 I have to tell it to exclude Hamcrest core. Then it won't have the dependency on 1.1, it will allow me to use the 1.3. So in my test now, the greater than is coming from as if by magic, Hamcrest 1.3. So hopefully that information, and it's all controlled in the Maven file, should allow you to experiment with which version of Hamcrest you want, and then give you the flexibility you need in your tests to model them as you want. Hi, I just want to show you a few things in IntelliJ for like kind of hotkey tips, things like that. So a couple of things that are important for me are over here in the project settings part. Now I have a few things on here that you may not in terms of, so let me just set this back to normal. So auto scroll from source, show members. So I think this is the default. This is typically what you see in IntelliJ. Now we've got a list of classes and we've got the package structure in here, and all of that's quite splendid. Now if I flatten the packages, I tend not to use this very much, but you can see that all the packages are now completely separate. So there's no longer a hierarchy of packages. So if we want to go in and see them, this is a very clear way of doing it. Whereas if I don't flatten them, then we get a hierarchy. And you can see here that I've got com.selenium simplified, which is caused by the compact empty middle packages. So if I take that out, now every single piece in the package hierarchy has its own separate branch. So let me put flat compact middle. Now things that I think are really useful is this auto scroll to and from source. So let me show you that. Sometimes if I'm in here like this and I move back and forwards and I've closed the various parts of the hierarchy down, I have no idea where I am in the package structure unless I go back up here and have a look. But what's convenient for me is this auto scroll to source and auto scroll from source, so that if I'm in something here, it shows up in the package structure. This is auto scroll from source. You can see we've now opened this up in the package. Now auto scroll to source means that when I just click on it, it opens up here. This is a really useful thing, I find, for navigating around. And before we finish up, let me just show you the show members. Show members is very useful. You saw this little icon appear here. That means I can now expand this to see what methods are in here. And I can jump back and forward to those. This is just a nice easy way of navigating around your project through the project pane. So there you go, this is just a quick overview of this particular part of the project window. I find that really useful. Okay, now I just want to give you a quick overview of some of the keyboard shortcuts that I use. These are the navigation ones. I'm not going to overload you with a lot of them, but let's have a look at some of the navigation ones. Now sometimes as you watch these videos, you'll see me walk through some code as we've got here. This is the implicit wait test, and you can see there's a choose to code in Java on the server side from Combo's implicit wait synchronization example method, which is annotated with a test. Now at some point, when you're doing your testing, looking through the example code, you'll want to find that method again. Now you can see here where it is in the package structure, but you may not have noticed that in the video. You may just remember we were dealing with implicit waits. How could you find that? Well, we have some shortcut keys that can help us. So if I want to find the class, I'm just going to do Control-N. Then we know it's the implicit wait test. So if I just start typing that, it will show up in the drop down. I can click to it and go to it. Great. Now if all you remember is the name of the test, well, we can do that too. If I do Shift, Control, Alt and N, and then start typing in choose to code, and it's one of these. It's the choose to code in Java on the server from Combo's implicit wait synchronization example. There we go, in the implicit wait test. And then the other one I'm going to draw your attention to is the find file, which is Shift, Control and N. And then I can type in the file name. So if I didn't know where in the package structure I'd put the Firebug file, there it goes. It tells me source test resources. If I'm looking for the use WebDriver fluently test, I can find the file for that. So we've got three that I've shown you there: Shift, Control and Alt and N to find the symbol, which is the method name or a variable or something like that. Shift, Control and N to find the file, and really important one, Control N to find the class. Now hopefully if you do that when you're following the videos, you'll find it much easier to find the code that we're working with. So with Firefox, you pretty much have to install Firebug and the Firepath plugins. You're going to see that in the next couple of videos. Because we're using Chrome now, and Chrome is the recommended default browser that we use, we don't need any extra tools. When the course started, Firefox was a better browser for doing this dev work. Firepath was the best way of getting the functionality we needed to let us do XPath and CSS selectors. The dev tools have come on a long way since then. And in Chrome now, if I do an inspect, we get the dev tools up. Let me just dock that in the browser so we can see. We have the benefit now, we can explore the same way that you've seen me do already. But now I can do searches. Now you're going to learn about CSS and XPath selectors in the next couple of videos, but I just want to show you how you're going to test and do this. So in the dev tools, if I do a Control F, I've got this little selector box at the bottom, and that says I can find by string or selector or XPath. So I can find the string P, and that will find it in the text. It will also identify the paragraph elements. I can do XPath to find the paragraphs, and it's told me there's 41 paragraphs in there. I can find by CSS selectors, so I can find the P1 element, and it will highlight it there. So I don't need to install Firepath in Chrome to use XPath and CSS selectors. The inbuilt find functionality will let me do that. So as you go through the next videos, and you see me doing all this work in Firepath, you can do the same things in the Chrome DevTools with the out-the-box find functionality. Now, the tools that I want to install into Firefox are Firebug. Firebug is a debugger that sits in here. So in order to install Firebug, I have to be in Firefox because it's a plugin. So this is the one we want, the latest one. and we're getting it from the actual Firefox plugin site itself. Oh look, no restart. So if I download that now, so that's it, adding it in. You can see here that I've got an inspect element option by default in Firefox. So there's the, do you want to install this? Are you sure? Yes, we are. Now you can see here I made a mistake. I clicked on the Firebug installation twice, so this extra dialog here is that mistake. Firebug has installed because the browser has refreshed, so I'm just going to cancel this dialog. So now, where we had previously an inspect, now I've got inspect with Firebug. And there it is. So Firebug gives us a console panel, an HTML view, which I find a lot easier than the internal one. The ability to search through the DOM, analyze the CSS. Oh. So cookies comes by default with Firebug now. I did not know that. That's good, so we will not be installing FireCookie. Excellent. So now that we've got Firebug, let's go get Firepath, which is also on the Mozilla add-ons page. Now, one reason for remembering the URL is that when you want to install this as part of your running Firefox in your automation, you're going to have to add it to the profile, which means you're going to have to download the actual plugin file. We're not going to cover that on this particular course. So let's restart Firefox. So what does Firepath give us? Well, if I go into inspect element with Firebug, I see now there's a new Firepath. So I can type in an XPath or a CSS. So let's see. Yeah, there's a whole bunch of paragraphs that have been found. And they have been identified in the browser. I can do the same thing with a CSS selector. So this is really good for experimenting with your XPath and CSS selectors. It's the main tool that I use when I'm doing my automation to work out what selectors I need. And there we go, that's the Firefox setup done. I will now be using Firefox for the remainder of this particular tutorial. Now it's time to have a quick look at data-driven testing. Now this is not WebDriver functionality. At this point, this is the functionality of the test runner, and we're using JUnit. You can get similar functionality from TestNG or using a BDD framework. Now, I've put this section in here so that you get the basics of data-driven testing, so that you can start using it in the real world. But really, this is not WebDriver, this is just use of the test framework that we're doing. So the basics of data-driven testing in JUnit. Now I have added 2 tests in here into the suite. I've added a basic data-driven test, and I've added a test which reads in CSV data. The fundamentals here, let me quickly show you this, are we create a test class that is said run with the parameterized class. So it's important that we're using a slightly different JUnit runner at this point. We're using the parameterized class runner. The other thing that's different, the class that we're using must have a constructor, because we construct the test class with the data that we are going to use. So the data that I'm going to have here is I've got a test which requires a number, a string that represents a function like plus, another number, and an answer, because I'm going to show you all this with a calculator application that we've got. What makes this important is that we have a method in the class which is annotated with @parameters, and that comes from the JUnit parameterized class .parameters. It's an annotation in there, and this is where the data comes from. Then everything else is the same. Basically, in the test, I use the values that have been set up in the constructor. Because what happens is JUnit, when it encounters this test with this parameterized class runner, calls the parameterized method in here, and what it does is it receives a collection of object arrays. You can see here I've got a collection, and I'm setting it up in here, and the collection is a set of arrays that have strings in it. Then JUnit iterates through this collection, and for every entry in this collection, it instantiates the class with the arguments. So this is num1, this will be the function, this will be num2, this will be the answer. It'll instantiate the class with this, then it will run all the test methods in the class for that instantiation. So all the tests are run in the class every time it's instantiated. I've only got one test in here, but if I had two tests in here, both of them would be run with this set of data. Because remember, it's in the constructor that the data is called, then each of the tests is run with that instantiated class. And when the test is run, you will see the test name with an array entry against it. So that's the basics in situ for JUnit. We create a class, we annotate it @runWith for the parameterized class, we make sure it has a constructor with all the arguments that we want to pass in, we allocate those to field variables, and we use those in our test. That's where we get our data from. We create a method in the class which is annotated with @parameters, and that returns a collection of arrays, object arrays, and this is what JUnit uses with reflection to pass in to our class. Everything else is the same, and it runs every test with the data that's passed in. So that's a fairly high level view. You'll see it better in context. I'm going to go through this in more detail in just a second. Okay, so why would you want to do that? Well, in the course, what we have is we have a calculator page here. So this is the Selenium Simplified Calculator. And it's a very simple form on the web page. I can type in a value here, I can choose a function, can type in a value here, I can say calculate. So 0 plus 0, that's what it's interpreted as, is 0. If I put in another one, 2 plus 2, calculate, we get 4. Now, the functional path here is always the same. I type in a value, I choose a function, I type in another value, I click calculate, I get an answer. The complexity here is in terms of the data scope. So if we were testing this and we wanted to do thorough testing on it, or complete testing, and hit whatever boundaries or whatever else we've decided needs to be tested, then it's the data we want to vary across. I want to make sure that I have different data values for the first number. I want to make sure that I select each of these functions and try them in different ways. I want to calculate, I want to check that the answer is the same. So I have a single functional path, but what is going to vary is the data scope. That's the point at which we want to start doing data-driven testing. And that's what we're doing here. So in this basic data-driven test, you can see that's the page that we're using, Selenium calculate.php, Selenium calculate.php. So let's have a quick look at this test running so you can see what running a data-driven test looks like. So you can see in the runner here, we've got 0, 1, 2, 3. That corresponds to the index in the collection that we're passing through. Then it's doing each of the functional paths with the data and checking the result. So that's pretty simple. That's what you should see when you start running this. And the basic reason for doing this is when you have a single functional path, but it's the data you want to vary, then you start using data-driven tests so that I don't have to write so many tests. I just parameterize a single test. Now, obviously, there's a whole bunch of different ways of doing this. I don't need to do it using JUnit test runner. I could do it with a simple functional path in a method and call it with different data values and name each test on its own. But we are demonstrating this at the moment using the JUnit data-driven functionality, and it's an easy way to get started once you get your head around it. So in the next lecture, I'm going to look at the way of setting up the data through an in situ class in the method. But that's what the tests look like when it runs. So this is the basic data-driven test. Now it's parameterized. I've got @run with parameterized class. I've got my constructor, which is expecting to be initialized with a number 1, the function, the number 2, and the answer. So as we just saw on the calculator, that's the first field, then the drop-down value, then the second field, then the answer we expect when we hit calculate. So I have a static method here called data. Because it's annotated with @parameters, this is what JUnit will call. And because it's static, JUnit can call it without instantiating this class. So it knows it has to run this class. It knows it has to do it with the @parameterized class. So the first thing that JUnit does is look for the static method that's annotated with @parameters, calls that method, receives a collection, and the collection itself contains objects, which are arrays, and then it iterates through that collection, instantiating the class each time. Then once the class is instantiated, it calls every @test method on the class. Now this is as simple as it's going to get, because here the @parameters is a very, very simple array. So you can see here what we do is we create a new object array. So this is the outside object. Then inside we've got an array of strings. Now if you basically just follow this pattern, you will be able to create the data that you want. And I'm returning it as a list, so it turns into a collection which is used by the JUnit. And you can see there's a string. Each of these are strings and they're used in the constructor. Then, because the constructor adds it all into fields, I don't have to do anything different in the test. So my test is very simple. I go to the page, I find the element for number 1, then I send in the keys that have been passed in as the array, as the data parameters. Then the same for number 2, pass in the parameters. Then the same for the function list. Because it's in a list, I just select I find the drop down, then I select the option with the particular value that's been passed in the data. Then I check, I click the calculate button, then wait for the answer to appear, and then check that the answer is what I expect. And that is correct. That's completely nonsense. No wonder these are always passing. There we go. So now I'm basically waiting for the answer to appear, then checking that the answer that appeared is equal to the answer we're expecting. And that's the essence of a data-driven test. And what's important here is that I've created the collection in situ. This is the easiest and simplest way of doing it, by creating it as an object array in here and having it pass through. I'm going to show you another example where this parameterized method reads it from a file. But essentially this method can do anything. This method can go off, call web services, read databases, do whatever it wants, so long as it returns a collection, and the items in that collection are arrays of objects. That's the essence of the JUnit test runner. So we've covered the in situ object creation. What we're going to do now is read the values in from a file. Now everything in this test is much the same. The test is exactly the same because the test relies on the data that's been put in the constructor. The app4 class is exactly the same. The constructor is exactly the same. The class name is slightly different, but we're running with parameterized class. Then we've got the constructor that takes the 4 values. The differences are that my static method, which is annotated with app parameters, instead of constructing the collection of object arrays in situ here, calls a method. In this case it's reading a CSV file. But remember, this could do anything. I could be calling a method which is going into the database, calling a web service, randomly making up data, generating random data. I've done that in the past as well. So this is where the flexibility of the data-driven comes in. So here, this method, all this does is given the path of a file, and in this case, I'm using the user directory that we're running from in the source test resources folder. You can see that down here. Source test resources, I have a CSV file. Here it is, CSV file, data-driven.csv, and that's what I'm telling this method to read. So what it does is it creates a buffered reader, opens up the file, but can't find it, displays an error, and then prints the stack trace, and then pretty much just carries on, because I don't really mind if the test doesn't run properly at this point. All I really want to do is protect it from itself and catch the errors and just write out the error messages into the system. I mean, effectively I could do a new runtime exception in here and stop the test. That would be a perfectly valid thing to do. So you can see we try and load the file, or we try and open the file. Then if the file is open, we read each of the rows, then split it on the delimiter that we're expecting. In this case it's a comma delimited file, could be a tab delimited file, like that, could be a space delimited file, whatever. Now there's not a lot of error handling in here, so if in the CSV file you start putting in a lot of spaces, that's what you're going to get through. I could cater for that in the test, but I haven't. I have some basic error checking in here that says we've got a row number, then I increment it so that if anything goes wrong, I throw an error message saying I couldn't read the value in this particular row. Then I try and close the file afterwards. And what this then does is it returns the array list of string arrays back through the method which JUnit has called. So if this all works correctly, JUnit will receive an array list of string arrays which contains these values, and then the test is exactly the same. So a lot of people get confused about this, but really there is no difference between reading an Excel file. You just use different libraries. Calling a web service, you just do different libraries. The important thing is that this method returns a collection of object arrays. That's the fundamental part of using the parameterized JUnit, and that the constructor is set up to receive them effectively.